Hello, Luke. Welcome to Lesson 49. So today we will be talking about the multiplication of polynomials. So this is kind of an extension of our lesson from yesterday where we discussed polynomials. Now we're going to look at how to multiply them. And we've actually been doing this for a long time. So in particular, we're going to be looking at multiplying binomials. So we'll be looking at that. But first, let's just quick review. What is a polynomial? And hopefully you have this down fairly well right now. But remember, a polynomial is a term or a sum of individual terms such that they are in the form ax to the n, where a, maybe I'll just do this, where a is a real number and n is a whole number, which is a positive integer or I should say a positive integer or 0. All right. So this is the form of a polynomial, and we could have polynomials being added to each other. So we could have a whole series of terms that look like this that are being summed together, and that would be called a polynomial as well. So if you recall, let's go to a different color. We'll go back to black. 3x squared would be a polynomial. 3x squared plus 4y to the third. This would also be a polynomial. In fact, we would give this a particular name. We would call this a binomial. This is just a review from yesterday. So this was a binomial. Remember, because it has two terms in it. Okay? And they're both polynomials. So we have a binomial. We also have maybe something that looks like this. 4 plus x plus z. This would also be a polynomial, and in particular, we could call this a trinomial, right? So this is all a review from yesterday. Today, what we're going to be looking at is how to multiply, in particular, binomials. So if I have something that looks like this maybe, 2x plus 4y, and I want to multiply that by another binomial. Maybe it'll be 3x plus 2y, something like this. If I wanted to multiply these two, this would imply multiplication here. How would I go about doing that? Now, in the past, we've done some multiplication involving binomials and even trinomials and even polynomials that are bigger than trinomials. But they've always been being multiplied by a single monomial, which I think we talked about that yesterday. Maybe we didn't. I can't remember, but it would be a monomial. I don't think we did. So this might be a little bit of a new term for you. Monomial. A monomial is just a single term. That's a polynomial. So you have the monomial, you have the binomial, and you have the trinomial. Okay? So there you go, another term for you. Write that one down. Maybe if you want to even go back to yesterday's class notes, you could throw that in there. It might make more sense to put it in that section. But a monomial is simply a single term polynomial. Okay? So in the past, we've multiplied binomials, but we've always multiplied them by a monomial. So we've seen things like this, 3x squared times 4x plus 3z, for example. Okay, we know how to do this. Remember, this is where we would use distributive property, where we would have to take that first term and multiply it by the first term inside the parentheses, get the answer to that, and then add that to the first term being multiplied by the second term inside the parentheses. Okay, that's the definition of the distributive property, right? Which take this one and multiply it by everything on the inside and add it all together. All right. Well, the same thing kind of applies when we have a binomial being multiplied by another binomial. Okay. The idea is we need to take each of the terms in this first binomial and multiply it by every term in the second binomial. All right, so let me try to clarify that maybe with some arrows here. So we would need to take this 2x and we would need to multiply it by the 3x, and then we'd have to multiply it again by the 2y and add those two together. All right, when we're done with that, we then need to take the 4y and multiply it by the first term in the second binomial, and then multiply it again by the second term in the binomial and add them together. And then we would take whatever sum we got with this first term, the blue ones, the blue arrows here, whatever sum we got with those, we would add that sum with the sums that we got with the orange arrows, and that's going to be our final answer. So the idea should make some intuitive sense here. We're just trying to take each term and multiply it by every term in the second binomial. Okay? So let's just do this and see what we come up with. So we'll start with the blue one. So the blue one, we'd have to take the 2x times the 3x. 2x times 3x plus 2x times 2y. 2x times 2y. Okay? So what's that going to give us? Well, 2x times 3x is going to be 6x squared plus 2x times 2y is going to be 4xy, right? So that is kind of the sum for the blue. We've multiplied everything in this second set by the 2x at this point. Now we need to multiply everything by the 4y. So let's do that part of it. So we have 4y times 3x, excuse me, 4y times 3x plus 4y times 2y. 4y times 2y. And then 4y times 3x is going to give us a 12xy plus 4 times 2 is 8. Y times y is y squared. So that is the sum for the orange. That's everything being multiplied by the 4y. Now we need to take those two and sum them up. So maybe we'll do that in a different color. We'll do that in red. So well, let's actually keep things consistent here. So we're going to take the 6x squared plus the 4xy. And again, I just took that from here. This is just the sum. And then we're going to add that. Maybe we'll do this in black. Add that with the orange sum, which is 12xy plus 8y squared. And if we look at that, do we see any like terms in here? By golly, we do. There's a like term with here and here, right? They're like terms. So we can add those up. So we end up with, as our answer, 6x squared. Now this 4xy and the 12xy, we can add those together and we get 16xy. And then we have at the end plus 8y squared. That's all of our like terms. We can't simplify any more. So therefore, this is the solution to this binomial being multiplied by a second binomial. So the process is very similar to what we were doing earlier with our monomial times our binomial. We just multiplied it through every term in the set of parentheses. We're really doing the same thing here. It's just now instead of having one term on the outside, we have two terms on the outside. And we have to take turns and multiply everything in the second set of parentheses by each of the terms in the first set of parentheses. Okay? So it's, in a sense, the concept should be pretty intuitive. It should feel right the way that we're doing this because you've done this other distributive properties so many times. Okay? Now, that being said, we are actually I'm going to create some room here because they don't show you this in the book, but I'm going to show you another way to multiply these out that's not as intuitive, but it's a nicer process that'll kind of get you to the answer maybe a little quicker than the way we did it the first way. So this way should make sense to you. The process should be clear. Now I'm going to show you a way to do it that the process isn't so clear. You'll just have to take a little bit on faith. But it's a little bit of a faster avenue to get to the solution. And later on, it'll actually help you solve these problems, and I should say simplify these problems a little faster. Okay, so let's take the same problem. We're going to take the 2x plus 4y, and we're going to multiply that by the 3x plus 3x plus 2y. And the thing I want you to write down in your notebook so that you can study this method, and actually in your notebook you should have it open to a page that says Lesson 49, Multiplication of Polynomials. And I would say maybe even write this problem down as an example inside your notebook, and then you can solve it in your notebook and you can refer back to this problem later when you're doing your seat work if you forget a step. So why don't you write that problem down. And then I am going to show you now a word that is going to help us remember how to multiply these. And the word is, wait for it, FOIL. Okay? FOIL. FOIL. All right. So very, very important word right there. The steps that we're going to do to solve this multiplication problem are going to be based on FOIL. Okay? So don't forget this word. In particular, don't forget how to spell this word. That's, I guess, what's very important. Okay? So the way FOIL works is we are going to do a process here, and the letters that form the word FOIL are going to tell us what to do. It's a way to remember things. So the first letter of FOIL is an F. Okay? F, and maybe I'll write this over here, and maybe we'll do this in red so it matches. F stands for first. Okay? So what that means is we're going to take the first term of our binomials and we're going to multiply them. Okay? So this term is our first term. It's the first term in the set of parentheses. In our second set of parentheses, this is our first term. Okay? So we are going to take this term and we are going to multiply it by this term. Okay? So that's going to give us 2x times 3x, which is 6x. All right. Now, then we move on to the next letter, which is an O. The O stands for outside. Okay. So for the outside, we're going to take this outside term here, right? It's to the farthest, outside. And then this is the other outside term. So we have this outside term and we have this outside term. They're the two on the outside edges of our problem. We are going to then multiply these two by each other. All right? So 2x times a 2y is going to give us 4xy. So we'll have a plus 4xy. Okay? Then we have our I. And I'll use a capital I. I stands for inside. So we did the outside. Now we do the inside. So we take the inside terms, this term, the 4y term, and the 3x term. And we're going to multiply these two by each other. Okay, so we have a plus 4y. Oh, well, back this up. We can do this in our head. 4y times 3x is going to give us 12xy. Right? Okay. Then we have the L. Maybe you can figure this out. But the L is going to represent last term. All right. So this is the last term in our first binomial. The 2y is the last term in our second binomial. We're going to be multiplying these two by each other. So we have a 4y times a 2y, which is going to give us an 8y squared. Okay? Now all that's left is to look at this expression that we have here and combine like terms. So we have 6x plus 16xy, adding these two middle terms, plus 8y squared. And if, oh, and I'm sorry, oh, we did something wrong. Oh, Jim. Yes, our first term, 2x. When we took our f for our first term. First, 2x times 3x. Hopefully you corrected me a long time ago on that. 2x times 3x is not 6x. It's 6x squared. I didn't multiply the two x's. So, yes, hopefully you saw that. And I stand corrected. But now if we look at our answer now, it matches what we had earlier. Okay? But we didn't have to do all of these steps. We just kind of drew our lines and got to where we need to be. Okay? So now I kind of drew these lines systematically. I mean, you don't have to draw the lines, and eventually you'll be doing this in your head. But what you do need to remember is the FOIL. Okay? That's what you need to remember so that you recall what to do first, what to do second, what to do third, and what to do fourth. Okay, so it's the first, the first, the 2x and 3x, and then it's the outside, and then it's the inside, and then it's the last. All right, and if you do enough of these, that is going to become second nature to you. So if you want to draw the lines, you certainly can. I know some people get a little creative and they use the lines to help them remember what to multiply first. The way this is set up, you can kind of visualize if you want, throw in a set of eyes, over here or something, and then you've got this kind of this smile, kind of this jack-o'-lantern look right here, right? If you really use your imagination. So anyway, I've seen people do that before too, if that helps. So, when you get to this binomial, you've got to draw, your eyebrow lines, this kind of forms the nose. You've got your eyes. So you just have to remember this line goes to here, this line goes to here, and then these two lines go underneath. It's totally up to you. If that helps you, that's great. If it doesn't, don't worry about it. But bottom line is remember the FOIL, because that'll help you solve these binomial products a lot faster than if you were to do it like we did over here and multiply every term. We're essentially doing the same thing, but we're just kind of using this way to remember how to do it. Okay? So let's try a couple of problems here and see how you do. I'll just take a couple from the book here. So if we have the problem 4x plus 5, and we multiply that by 3x minus 2. Go ahead and do this. So what would we do? Well, remember FOIL. So first would be here. The first terms, FOIL, first. 4x times 3x is 12x squared. FOIL, the outside is next. So the outside, we end up with a positive 8x. Oh, excuse me, we don't end up with a positive 8x. I have a positive 4x. I'm multiplying that by a negative 2. Positive times a negative is a negative, so I have a negative 8x. Watch out for those signs. And then I have the inside. Positive 5 times positive 3x is going to be a positive 15x. Then I have the last. Positive 5 times a negative 2 is a negative 10. I look for like terms, and we're going to have 12x squared, and I can see that this and this are like terms. Negative 8 and a positive 15 is going to give me a positive 7x minus the 10. And there we go. That is my solution. All right? So it's as simple as that. Not hard to do if you can remember the FOIL. So let's try another one. This one I want you to do on your own first, and then we'll do it together. So if I have 4x plus 2, and I want to multiply that by an x minus 5, go ahead and do that on your own. Pause the video, and then we'll do it together. All right, so hopefully that went well for you. Let's just use our FOIL. So FOIL would be f for first. 4x times x is 4x squared. Outside, 4x times a negative 5 is a negative 20x. And then inside, positive 2 times x is a positive 2x. And then last, a positive 2 times a negative 5 is a negative 10. And then we can combine like terms. We have 4x squared minus 20x and a positive 2x are like terms. So we end up with a minus 18x minus 10. That is our solution. Very straightforward. Once you get the hang of these, they're actually kind of fun. All right. Let's keep going. Let's try another one. 4x plus 2 times a 3x minus 5. Okay, so, oh gosh, these are very similar. But go ahead and just take that one and try to do it on your own, and then we'll do it together quickly. All right, so let's do our FOIL. FOIL f first. 4x times 3x is 12x squared. Don't do the same thing I did and forget to multiply those x's. It's got to be x squared here. And then we have our outside. 4x times a negative 5 is going to be a negative 20x. Then we have our inside. 2 times 3x is a positive 6x. And then we have our last, our 2 and our negative 5, which is a negative 10. We combine like terms. We have a 12x squared minus a 20x, positive 6x is going to be a negative 14x minus 10. That is our solution. All right? Very good. All right, so let's try one more that you might see in your seat work, and that might be something that might look like this. If I have 3x plus 4 squared. All right, it looks a little bit different than the other problems, but what we need to recognize is that this is essentially a multiplication problem of binomials. So what does this mean, 3x plus 4, quantity squared? All right, well, it would mean 3x plus 4 quantity times 3x plus 4, right? That's all that squared means. It just means we're taking this and multiplying it by itself. So if I have 4 squared, that's equal to 4 times 4, right? Well, in this case, the only difference is I'm having a set of numbers. So if I have 3 plus 2 inside of parentheses and I'm squaring it, well, that would be 3 plus 2 times 3 plus 2. You're just squaring this whole set of parentheses. Everything that's inside these parentheses needs to be multiplied by itself, okay? So when you see a set of parentheses raised to a power, it just means everything in that set of parentheses, that whole bucket, is being multiplied by itself, however many times we have the power up here, okay? So 3x plus 4 squared means 3x plus 4 times 3x plus 4. We can then use our FOIL. So we've got first, 3x times 3x is going to be 9x squared. Outside, 3x times 4 is going to be a positive 12x. Inside, positive 4 times a positive 3x is going to give you a positive 12x. Last, positive 4 times a positive 4 is a positive 16. And then adding our like terms, we would have 9x squared. Plus, these two are like terms, so we'd have plus 24x plus 16. And that would be our solution. So don't let this form throw you off. It's just, again, a multiplication problem of binomials. All right. Let's end the class with just kind of a challenge problem. Let's talk about what we would do if we were multiplying, let's say, a binomial, and I'll just create one here. How about a 3x minus 2? There's our binomial. And what if we're multiplying that by a trinomial? And I'll just make something up here. Something like this. So now I've got a binomial multiplied by a trinomial. And when we have that, FOIL does not work. Sad, sad. FOIL does not work. The only time FOIL works is when we have a binomial being multiplied by a binomial. I need to stress that because you might try to use FOIL for something like this and you're going to get hopelessly confused and probably not get the right answer. So once again, FOIL, maybe I should write that down. Maybe we should write this in our notebooks. FOIL can only be used when multiplying two binomials. Two binomials. Okay? So don't forget that. It has to be two binomials. This has one binomial right here, but unfortunately this other one, well, this is not a binomial. This is a trinomial. We have three terms, right? So how would we multiply this? If we can't use FOIL, we have to kind of go back to our original plan, which is simply to take each term by itself and multiply it by all of the other terms in the other set of parentheses. Okay, so we're back to square one. Unfortunately, there's just no shortcut here that I'm going to show you today. This is just the way we're going to have to do it. So we take our first term, and we're going to multiply that by the first term over here. And we're going to get 3x times 3x squared, which is going to give us 9x to the third. Then we need to take that first term again and multiply it by the second term over here. So now we have positive 3x to the fourth. And then finally, we take that same first term and we multiply it by our third term. If we had a fourth term, we'd have to multiply it by the fourth term, and so on. So taking the 3x times the 4, we're going to get a positive 12x. Okay? And we've reached the end of our terms, so we're now done with this first term. We're ready to go on to the second term. So now taking that second term, we'll take the negative 2 and we'll multiply it by our 3x squared, our first term here. So negative 2 times a 3x squared is going to give us a negative 6x squared. And then we'll take that first term and multiply it by the second term. Negative 2 times x cubed is going to be negative 2x cubed. And then once again, negative 2 times our third term is going to give us a negative 8. All right. Now we can just combine all of these. So do we have any like terms? Well, we have a 9x cubed, and we have another x cubed over here. We can combine those two. So 9x cubed and a negative 2x cubed, that's going to give us a 7x cubed. All right. Then we have a 3x to the fourth. He's all by himself. There aren't any like terms with him. And then we have a plus 12x. Nothing there either. And then we have a negative 6x squared. Nothing there either. And then we're left also with this negative 8 over here. He's all by himself. And then the last thing that we should probably do is write this in some sort of a standardized form. And the best way to do that is, as we've discussed earlier, is to write it in descending order. So take the variable to the largest power, write that first, and then write it in descending order after that. So the largest power for our variable x is 4. So we're going to write this as 3x to the fourth. We'll do this term first. And then we have a 7x to the third, so we're going to add that, 7x to the third. And then we have a minus 6x squared. We'll put him next. And then we have a plus 12x. And then we have our minus 8 at the end. So we've just written it down in descending order of powers for the variable. And that would be our solution. So keep that in mind. The general idea is just taking each term and multiplying it by all the other terms in the second set of parentheses. So I'm going to give you one more of these problems to do on your own, just to give you some practice at it before you start working in your seat work. So let's say I've got 2x plus 3, and I want to multiply that by, we'll say x squared plus 3x plus 4x squared again. Go ahead and multiply that out, and then we'll do it together. All right, so let's do this. We're going to start with our first term, the 2x, and we're going to multiply that through. So a 2x times an x squared is going to give us a 2x to the third. Multiply it by the next term, we're going to end up with a 6x squared. And multiply it by the third term, we're going to end up with an 8x cubed. And then we have to do the second term. So we have a 3 times x squared is going to give us positive 3x squared. And then 3 times the 3x is going to give us a 9x. And then the 3 times the 4x squared is going to give us a positive 12x squared. And then we can combine any and all like terms. So looking at that, if we have a 2x to the third, we have another 2x to the third, or x to the third, excuse me, right here. So we can certainly combine those, and we get 10x to the third. And then we have a 6x squared and a 3x squared. Well, that's 9x squared. And then another 12x squared. Well, that's 21x squared. So we have plus 21x squared. And all that's left then is the 9x. So we throw him on at the end. And in this case, it's already written in descending order. We have x to the third, x to the second, x to the 1. So this would be our solution. All right? Very good. So it's not a complicated lesson here today. I think it should be pretty easy for you. But we will stop here and continue tomorrow. And good luck on your seat work.